All right, only 2 days of videos left, so let's go ahead and pick up where we left off yesterday. We are working on question 25. It's our first question today. We have x plus 5 times x minus 4 is equal to 0. Well, this is a question we talked about not too long ago, dealing with our zero product property. What we have here in this question is a multiplication question that's equal to 0. Well, what had to be true if you multiplied and got 0 as your final answer? One of those pieces had to be equal to 0. Well, that's the question that we're going to write. We're going to take the first parenthesis, which is x plus 5, that could be equal to 0, or we're going to take the second parenthesis, the x minus 4, that could be where the 0 is sitting as well. The first equation, to get the x by itself, will subtract 5, so 0 minus 5 is negative 5. The second equation will add 4, so 0 plus 4 is 4, and we have two different answers for x because we have two parentheses on the question. The next two problems on 26 and 27, we're going to have to factor them first. So x squared plus 5x plus 6 is equal to 0. Well, those three pieces do not have anything in common, so I can't pull out a common factor. The question already equals 0, so we didn't need to do any rearranging as well. We notice we have the plus sign, which tells me the signs will be the same, and they're both going to be positive because of the plus that's in the middle. What multiplies to get 6? That adds together to make a 5. That would be 2 and 3. So we have x plus 2 times x plus 3 is equal to 0. Now, just like question 25, we have our multiplication question that's equal to 0. How do we set up this question? The x plus 2 could be equal to 0, or the x plus 3 could be equal to 0. Both of these equations now require us to subtract. So 0 minus 2 is negative 2, and 0 minus 3 is negative 3. Again, we started the question with an x squared, so we have two final answers in our questions, the negative 2 and the negative 3. One last question along this line, number 27. 6x squared minus 30x is equal to 0. Once again, the equation already equals 0, so we don't need to do any rearranging. However, this time we do have a common factor that we can pull out to the front. 6 and 30 would both divide by 6, and both of these pieces do contain a common x. When it came to the variables, we took out the one that's the smallest, so I'm just going to take out the x. So pulling out the 6 and the x. Well, 6 divided by 6 was 1, and then I had two x's. I took one out to the front, so we just had one x left over. Drop down the minus sign. 30 divided by 6 was 5. We had one x to start with, but we took out one x, so I don't have any x's left behind that number 5. We wrote our multiplication question that is equal to 0, so one of these factors has to be equal to 0. The first factor is my 6x, so I wrote 6x equals 0. The second factor is my x minus 5, that could be equal to 0 as well. The first equation, to get the x by itself, we're going to divide by the 6. 0 divided by 6 would still be 0. The second equation, add 5. So 0 plus 5 is 5. Again, we started with an x squared, and again, we have two final answers, our 0 and our 5. Let's move to question 28 as our next questions. These were the rational equations that we talked about, and we discussed two methods for how to solve these. We'll see both of these as we're working through these questions. So on number 28, we have 4 over x equals 8 over x plus 4. Well, what did we do when there was one fraction on both sides of the question? The correct process that we used was our cross multiplication. So I'm taking the 4 multiplying by the x plus 4, and the x is being multiplied by the 8. So I wrote 4, and then I put parentheses because there's two pieces there. So 4 times x plus 4 equals x times 8, and I would just put the 8 first, so 8x. On the left-hand side, we need to distribute to get rid of those parentheses. So 4 times x is 4x, and 4 times 4 is 16, and that's still equal to 8x. The x that we're solving for is on both sides of the question. Now, since the right side only has the x, I took this x from the left side and I moved it to the right side. To do that, I would subtract my 4x. So 8x minus 4x is 4x. My equation now says 16 equals 4x. And now to get the x all by itself, notice it's on the right-hand side. So how do I get rid of that 4? Divide by 4. 16 divided by 4 gave me 4, and there's my answer for x. Don't forget on these rational equations, though, you always had to check your answer. Remember, in a fraction, the denominator never can be a 0. So let's take a look at this answer that we got of 4. If I put 4 into this first fraction where the x would be, well, that would just make the denominator 4, so that's okay. If I put 4 into this denominator for the x, well, then it says 4 plus 4, which is 8. It's okay for me to have a fraction with a denominator of 8, so my answer of 4 is acceptable. Let's move on to our next question, number 29, where we're going to use our second method to help us solve because there's two fractions on the left-hand side. So 9 over 3x plus 15 over x is equal to 6. The second method that we talked about for how to solve these rational equations was to multiply by the common denominator. We talked about earlier in our packet here how to pick out the common denominator. We need to look at everything that we have, and I included the most times I see it. Well, in the denominator, I see a 3x and an x. Neither one of those are adding and subtracting, so we don't need to do any special factoring first. What do I have? There's the number 3, so that's going to be part of my common denominator that we're going to multiply by. The first fraction has 1x in the denominator. The second fraction also has 1x in the denominator. It just shows up once, so I need to include that one letter x. So I took the entire question inside parentheses, and I'm multiplying by in yellow there the common denominator, which was the 3x. Remember, if you want to, you could write that as 3x over 1 if it helps you to see it in the fraction format. Now, what I like to do at this point of the question is see what does it reduce with from the denominator, and then we multiply by what's left from the numerator. Well, this first denominator is 3x. So the 3x that I'm multiplying by would completely cancel out the 3x in the denominator, which means I would just be left with the 9 from the numerator, and I drop down the plus sign. Well, the second fraction just has an x in the denominator, which means it would only cancel the x from my yellow common denominator, which means I'm left with the 3, and I'm also left with the 15. So I have 3 times 15. Now, this last part with the number 6, there's not a denominator. I mean, technically, it's over 1, which means nothing's going to cancel from the yellow there. So I have the 3, the x, and the 6 left over. I just put the two numbers side by side. So there's my 3 and the 6, and there's the x that we have as well. Let's go ahead and multiply here. So I have 9 plus 3 times 15 was 45. And on the right-hand side, 3 times 6 was 18 with the x. The left-hand side has two like terms. 9 plus 45 is 54. So 54 is equal to 18x. Notice the x is on the right-hand side. So how do I get rid of that 18? I would divide 54 divided by 18 gave me 3. Before I move to the next question, we got to check, is this answer acceptable? If I put 3 right here, well, 3 times 3 is 9, and that's okay for me to have a 9 in a denominator. If I put 3 right here, well, that's all that I would have. And again, it's acceptable for us to have a 3 in our denominator. Let's finish this section with number 30 here. We have 3x minus 1 over x plus 3 is equal to 2x minus 4 over x minus 2. Well, this goes back to the same method that we did on question 28, where I have one fraction equals another fraction. How do we do that process? We need to cross multiply. Now, we need to be careful when we're cross multiplying because each piece has two parts, so I use parentheses. The 3x minus 1 is going to get multiplied by the x minus 2. The 2x minus 4 is going to get multiplied by the x plus 3. Now, which order you put them on each individual side is okay. Like if you wanted to put the x minus 2 first, then the 3x minus 1, that's not a problem. Both sides has two different parentheses that's being multiplied, so we needed to FOIL to do that. On the left-hand side, 3x times x was 3x squared. The outside, 3x times negative 2 was negative 6x. The inside, negative 1 times x is negative 1x, or just negative x, and negative 1 times negative 2 is positive 2. Go to the right-hand side. The first terms, 2x times x is 2x squared. The outside, 2x times 3 is plus 6x. The inside, negative 4 times x is negative 4x. And then my last terms, negative 4 times 3 is negative 12. On each individual side, now we're going to collect our like terms. On the left-hand side, we have these two pieces right here that both have the x, and the same thing on the right-hand side, we have two pieces that both contain an x. So the left-hand side is 3x squared minus 7x plus 2. So I did negative 6 minus 1, and that was negative 7 with my x. On the right-hand side, we have 2x squared plus 2x minus 12. So how did I get that? We combined those two like terms that I underlined. 6x minus 4x was 2x. We've simplified everything that we could on each individual side. We have an x squared, which means I need to set this equation equal to 0. I'm going to take all three of these pieces from the right side and move them to the left side. So starting off with a 2x squared, I would subtract it over. 3x squared minus 2x squared would just be 1x squared or x squared. To move the 2x, again, we're going to subtract. So at negative 7x minus 2x is negative 9x. And then my last piece, this one's going to require us to add it over. So 2 plus 12 is 14, and now our question equals 0. Well, just like we saw even back on number 26 a few minutes ago, when our question equals 0 and we have the squared term, we need to factor. We see the plus at the end, which tells me the signs are the same, but the minus in the middle tells me both of these signs would be minuses this time. What multiplies to make a 14 that adds together to make a 9? It is 2 and 7. So I have x minus 2 times x minus 7 is equal to 0. We have our two parentheses equal to 0. One of those factors has to be equal to 0. So x minus 2 could be equal to 0, or the x minus 7 is equal to 0. The first equation, add your 2 over, so x is equal to 2. And the second equation, add your 7, so x is equal to 7. Again, before you move on, make sure you're checking these answers. If we start with 2 over here, 2 plus 3 is 5, so far so good. The second fraction, 2 minus 2 is 0. Uh-oh, I can't have a 0 in the denominator, so I cannot include this answer of 2. Hopefully my second answer works, so let's try 7. 7 plus 3 is 10, so that's okay. 7 minus 2 is 5. Again, that's okay. So the only answer that I would be able to give here is just the number 7 on the question. So don't forget, on 28 through 30, you always need to check your answers to make sure that they don't make a denominator of 0. So tomorrow we'll finish up with questions 31 through 40, and that will wrap up our review as we're getting ready to take that fourth quarter test next week.